wanted to make a video going over a few questions before you do your 2.1 through 2.3 review, because there's a response question there that I think you might have a little bit of trouble with unless you have seen one like it worked out. There's also a couple of questions that I want to look at as well, so for the multiple choice section. So this is similar to the free response question that you're going to have on your 2.1 through 2.3 review. The graph of the function f and the table of selected values of f of x are shown above. The graph of f has a horizontal tangent line at x equals 4, is concave down for 0 to 6, and is linear for x is greater than or equal to 6. The first thing it asks us to do is to approximate the value of f prime of 5.5. Using the data for the table, show the computations that lead to your answer. So first of all, it's really important to know which is which here. We're given f prime of 5.5. So on the graph, we're looking about right here. On the table, we're looking right here. And so we can use our values to approximate. Now, it's important to use these two together because you might, if you're just using the table, I told you guys to pick the points closest to the point that you're looking at. So you might choose to use 5 and 6. However, if we look at the graph right here, at 5, we have this point right here. At 6, it's jumped down here to -1. So if we draw a line that has this slope, that really would not be a good approximation for the slope at 5.5. So in this particular case, rather than using 5 and 6, we're going to get the most accurate estimate if we just use 5 and 5.5. So we want to find the slope between these 2 points. So we've got 5 and 3.455 is 1 point. Oh, good gracious. And then we've got 5.5 and 3.244 for our second point. So you're just using slope formula. Label everything you do whenever you're working on a free response question. So we're saying f prime of 5.5 is approximately, do not put an equal sign there because it doesn't equal, we're estimating right here. And we're going to say 3.244 minus 3.455 over 5.5 minus 5, and so when we do that, we are going to get, let's see, 3.244 minus 3.455 is going to give us negative 0.211 over 0.5, and that is going to give us negative 0.422 whenever we do this. So our f prime of 5.5 is approximately negative 0.422. So that is the answer for part A. So next, it says, is there a value of x for 0 less than x less than 6 such that the limit as h approaches 0 of f of x plus h minus f of x over h equals 0? Give a reason for your answer. And so it asks for this limit here, and what they're really wanting to make sure you know is that this is your limit definition of a derivative. So this would be f prime of x. And so they're really asking you, between 0 and 6, is there a value where the derivative equals 0? So first of all, I would state that f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, so that the reader knows that you understand that this is the derivative. You could also say that the limit as h approaches 0 of f of x plus h minus f of x over h is the derivative of f. You could write it out in words if you would rather. And so we want to know if the derivative is ever 0 between 0 and 6. And so here we've got to look at this graph right here, and right here at this maximum point we are going to see that your tangent line switch from being positive here to being negative. So it appears that right here we will have a horizontal tangent line, and in fact they tell us we have a horizontal tangent line. The graph of f has a horizontal tangent line at x equals 4 right here. And so since you have a horizontal tangent line, the slope of that horizontal tangent line is 0, which means the derivative is 0. So we're going to have to explain that. So we would say the graph of f has a horizontal tangent at x equals 4. So f prime of 4 has to equal 0, or you could say the derivative or the slope of the tangent line at x equals 4 is 0. And then just to be safe, therefore there is a value on 0 less than x less than 6 such that such that the limit as h approaches 0 of f of x plus h minus f of x all over h equals 0. So you'll notice right there at the end, this is a good thing to do on free response questions. I really just restated the question in my answer. They said, is there a value of x on 0 to 6 such that this equals 0? And so I gave my reasoning about the tangent line, and then I said, therefore, there is a value on this such that this is true. So I just restated the answer to the question. And so that's a good practice to use whenever you're doing a free response question for AP. And that is all we have to do for that. This is our reason for our answer. We're going to go on down to C. And it says, for each of the following limits, find the value or explain why it does not exist. And so, for this problem, we've got to look at what we're looking at. We see f of 6 plus h minus f of 6 all over h. We see here f of 6 plus h minus, all of these are the same here. And so, let's think about our limit definition of a derivative. Limit definition of a derivative is h approaches 0 of f of x plus h minus f of x all over h. Well, if you look at this, it looks very similar to the equation that we have here, except for instead of x, we have a 6. And so what we're seeing here, this, we can think this is f prime of x. Well, if we want to know f prime of 6, then that would be the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h. So this is the derivative at 6. Now we look at it from the right, from left and at 0. So for each one, we're supposed to find the limit and explain why it, or explain why it does not exist. And so for our first one, for I here, we have the limit as h approaches 0 from the right of f of 6 plus h minus f of 6 all over h. And so whenever we look at the graph up here, we can see on the right-hand side, as we approach from the right-hand side, we have a nice straight line here, which is really good because that means we can find the slope of that line really easily. And so the slope of this line right here is just -1/2. So our slope right here, our derivative at 6 is -1/2 as we approach from the right-hand side. Okay, so they gave us the easiest part first. This is the easiest part because we have that nice straight line. For the second part, we're looking at our derivative from the left, and we can see that here we have this open circle, and this is really just not probably going to work out here. If we think about what is happening here, we've got to think about this a little differently. So for the second one, we've got the limit as h approaches 0 from the left, and we've got f of 6 plus h minus f of 6 all over h. Now, f of 6 is a value. We know f of 6. F of 6 in our graph is 1. So f of 6 is 1. So we've really got the limit here, limit as h approaches 0 from the left of f of 6 plus h minus f of 6, which is 1, all over h. And so if we look at what's happening here, if we're approaching 0 from the left, if we're thinking about these values, well, that means that h would be -2 and -1 and -1/2. And so we're approaching f of x, we're approaching from the left-hand side here. And as we approach from the left, our value approaches 3, but doesn't quite get there, but approaches 3. So this limit here, the limit as h approaches 0 of f of 6 plus h is going, is going to be 3. And then you've got a -1, and then you can think of the limit as h approaches 0 from the left of h. And so this limit right here, this is 3. The 1 here is just 1, and then you'll have a 0 in the denominator. So this is 2 over 0. So what we'll say here is that the limit at x, actually let me say the limit does not exist. Because the limit as x approaches 0 from the left of the denominator or numerator approaches 2, while the limit as x approaches 0 from the left of the so we know that we would not have a limit at that point. Now, I think that part is really difficult to sort of work through. In fact, I made sure I double-checked the answer key on this one before I went over this. Part 3 is not quite as difficult. Now, if you got part 2 right, then there's a really simple answer for part 3, and you can just say that that the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h does not exist. Because the limit as h approaches 0 from the left of f of 6 plus h minus f of 6 all over h does not exist. Okay, so that is one of the possible answers, and if you got number 2, the second part right, then it's probably the easiest thing to say. However, let's say that you don't really know what to do with part 2 and you ended up leaving it blank, or you're really unsure of your answer. That happens a lot of times on AP free response questions, but you can still get some points for part 3, because if we look at the graph at part 3, we have a jump in the graph at part 3. So we could say here, you don't have to put both of these, we could put that f of x is not continuous at x equals 6. Well, I can have this, isn't it? Yes, 6. At x equals 6. So the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h does not exist. I'm going to cheat here and put the any right there. So we could also use that as an answer. Okay. So that goes over that free response question. You're going to have one similar to this on the review. I also wanted to look at this problem right here. So for this problem, it says the graph of a function f with f of b greater than f of a is shown for the interval from a to b. The derivative of f exists for all x in the interval from a to b except at x equals 0. How many values of c, for a is less than c is less than b, does the limit as x approaches c of f of x minus f of c over x minus c equal f of b minus f of a over b minus a? And so I think these are a little bit confusing because of the notation that is used here. And so f of b minus f of a over b minus a, this part right here, this is our slope formula, and this is the slope between the points a f of a f of a and b f of b. So we're looking at the slope between these lines, and they purposefully told you that f of b is greater than f of a. And the reason that they did that is so that you would know that this line right here is increasing. So this line right here has a positive slope because f of b is a little bit higher than f of a. And so we want to know how many times that this limit as x approaches c of f of x minus f of c over x minus c, we'll know how many times this value equals that slope through the endpoints. And this right here is our derivative at c, or our derivative at some point c. Yes. So we're looking really just for where we have this parallel tangent line. So right here, you would have negative tangent lines everywhere here. Down here somewhere, you're going to end up with a parallel tangent line somewhere here. Then, as we increase, probably we're going to have another one about right here somewhere. I'm probably not drawing them in quite flat enough. Here, negative tangent lines, negative tangent lines. Doesn't appear to have one here. We don't have a tangent at all right here because we've got this sharp turn. Then when we increase and flatten back out, we're going to have another one right here. Negative tangent lines here, so those don't apply. And then we turn back up, and we should have another one somewhere around here. So we've got 1, 2, 3, 4 places where this occurs, so 4 would be our answer here. So hopefully that'll help you with one of the questions that you'll see on your review. And then the last thing I'm going to do is just tell you that on your review, the answer to number 3 is going to be C. Let me double check and make sure that's there. Yes, so number 3 I really didn't want to get, I didn't mean to give you, but now that I have assigned it, I am having a hard time figuring out how to remove it from the quiz. So I'm just going to tell you the answer. The answer for number 3 is C. Don't worry about figuring that one out. Put C and move on. Answer the rest of the questions there. So I hope this helps with your assignment. If you have any questions, let me know.